Okay, now we're actually looking at vectors from three aspects, and they get more complex as we go through this. We did the perpendicular vectors already. Now we're going to do one which one is perpendicular, or actually I shouldn't say perpendicular. One is a direction like north, south, east, and west, and the other is a non-perpendicular vector to that. Okay, and then the last one will be two of these non-perpendicular vectors. So let's get through this process here. We have a bird flying again at 12.5 meters per second, but now it's going to be going 30 degrees north of west. And it's met by a wind that is 5.0 meters per second west. What is the resultant velocity? So just like before, we're going to make a drawing of this, but you're going to see that we no longer have a right triangle. So things are going to change up a bit. So let's do this. Alright, so we're told that we have 12.5 meters per second, 30 degrees north of west. Okay, so if this is west, north of west is going to be over here, and it's 12.5 meters per second, so it's going to be the longer of the two vectors. We'll say it's going to look something like that. We'll go up this far right here, and this is going to be 30 degrees right here, and this vector right here then is 12.5 meters per second. All right? The second vector is 5 meters per second west. Okay, so I'm going to draw that in blue. So 5 meters per second west is going to look something like this. So this is 5 meters per second. And it's right on the axis. So when I draw my corresponding vectors here, this would be about 5. Very poorly drawn because this thing's kind of out of line. And then this right here, shouldn't use that level one, but oh well. I'll get over it, as will you. And let's say that's what it's going to look like. And so the resultant has to start from here and end up over here. So when you draw that line, it will look something to that effect right there. Now you can see that we have two triangles. We have this bottom triangle here, and we have this top triangle here. Now since this one is right on the direction, this is the triangle I want to use. So I have 5 here, and I have 12.5 here. I'll put the 12.5 here as well. I have 12.5 here, and I have 5 here. So I'm picking this triangle right here. Okay, so the missing C is that is not necessarily a hypotenuse, but it's the missing side. Now, had that been a right angle right here, then we could have used the Pythagorean theorem, which states that C equals the square root of A squared plus B squared. But we don't. So we think, well, shoot, now we can't even use the Pythagorean theorem. Well, that's not necessarily true. We can use it, but we got to have a correction factor. So that correction factor takes care of the loss of that 90 degrees by throwing in a cosine in combination with all the other things going on here. That correction factor is minus 2AB cosine angle C. This is the correction factor. And if C were 90 degrees, a right angle, the cosine of C is 0, and this whole thing drops out, which is what it's supposed to do. So this is a really good way to deal with the loss of right angle by including that in the correction factor. So, the question is, what is the measure of that angle right there? Well, we know that this angle right here is 30 degrees. Oh, I'm sorry, this angle right here is 30 degrees. So I'll put that right there. This angle right here in green, going from here all the way over to here, those are consecutive angles in a parallelogram. Now, if you remember from geometry, and again, geometry is going to keep rearing its ugly head in this class, that the two angles have to be supplementary. That means they add up to 180 degrees. So this angle right here is 180 minus 30 degrees, which is 150 degrees. And that is opposite this angle C. This 5 here is opposite this angle here, and this 12.5 is opposite, the 12.5, this one right here, is opposite over here. So we got a number of options to use here. So we want to find C. All we need is to use this angle here that's opposite C. If this is side C, then this is considered angle C. This is side C. This is angle C. So now we're going to plug in numbers. And it doesn't make a difference what A and B are. They're interchangeable. But in this case, I'll go ahead and put your C here. I'll put the square root of 12.5 squared plus 5.0 squared minus 2 times 12.5 times 5.0 times the cosine of 150 degrees. And close that. Plug that into a calculator, and it turns out that we get 17.0 for that distance. That resultant vector displacement is 17.0. So this is going to be then, let me put that in red, follow that along. That is the resultant, that's my C, and that's 17.0 meters per second. So now the question is, what is that angle in relation to this? Now it looks like it's 30 degrees, but you can see there's a little sliver right there. So I can't say that that's 30 degrees. So I got to come up with another way. Now before I go any farther, by the way, this correction factor for the Pythagorean theorem has a name. This is called the Law of Cosines. So that needs to go into your toolbox. But I have that mentioned later on in the script, so you can wait on that, or you can pause it right now. You'll see it again. But now we need a way to find an angle. So here's the deal with this one. We know this angle right here is 150 degrees. We know this side right here. We want to find out this angle right here. This is the missing angle right there. From the red to the blue. So that we'll just call angle X. It'll be X degrees. And that is opposite this side of the triangle, which is your 12.5. So what the tool that we can use for this is something called the Law of Cosines. And that is that the sine of angle A over the side A is equal to sine of angle B over the side B. And again, it doesn't make a difference. Again, letters are irrelevant over here. You just pick two angles, you call one A, call one B, go from there. There's no definitive ABC here, and there's no definitive AB here. They're just letters, they mean nothing. Okay, so the sine of angle A. So we know that this angle right here, we're going to call that angle A now, instead of C like we did over here. All right, so That is 150 degrees. So that's a sine of 150 degrees over the side that is opposite that, which is the 17.0 meters per second, equals the sine of B. That's that sliver, that extra degree. In fact, I'll just go ahead and call that the sine of X. Why not? And the side opposite of that is 12.5. Now, when you do the math on this, you gotta be careful, because this is going to be 12.5 times the sine of 150 degrees equals 17.0 meters per second. Actually, I'll just drop the meters per second, because we know that the answer is going to come out in degrees. They'll just get in the way. Times sine of X. So, you get this by itself, this is 17, we have to get rid of 17.0. So that means sine of X is going to equal to 12.5 times the sine of 150 degrees over 17.0. But we don't want the sine of X. The sine of X is whatever this turns out to be. Now you can calculate that if you want. I like to do it all in one step, because if I make a mistake, I don't have to go through a calculator and change 2, 3 steps, whatever. I can just change it in one step. So what I'm going to do here, in order to find X, I have to take the inverse of the sine of X. Okay? So that means the inverse of this is going to be X is equal to the inverse sine of this whole conglomeration. 12.5 times sine of 150 degrees, and that'll be in parentheses, by the way, in your calculator, so make sure you close that parentheses or things will just go haywire, over 17.0. You punch all that in your calculator, inverse sine, 12.5 times sine 150, close parentheses, divide by 17.0, you're going to get your answer. And your answer turns out to be 21.6 degrees. So that means this sliver of an angle right here is 21.6 degrees. So X is 21.6 degrees. And you can take a look at this, you can see that is going to be 21.6 degrees north of west. So this is going to take a little adjustment. It isn't that much different at the beginning. When you have to use the Pythagorean theorem, you still have to use the Pythagorean theorem, but you've got to have that correction factor of negative 2ab times cosine c. The angle part is probably going to be the one that's going to challenge you the most. But if you just identify what's A, angle A, what's side A, what's angle B, what's side B, and then just dump it in there and use your mathematical skills, you come out looking at this answer right here. So, your practice problems. Oh, here's your two tools for the physics toolbox. Square root of, and these should be squares, and I'll fix that before you get the square. A squared plus b squared minus 2ab cosine c. And the law of sines, sine of A over side A equals sine of B over side B. And your practice problems are shown here. You can pause it and copy that down or whatever. But good luck to you.